Hello there. We're going to solve these quadratics by completing the square, and they may or may not involve imaginary numbers. Okay, so time to play wishful thinking. So I would really like it if this were a 9 here. That would just be perfect. So if I'm going to add that 9 over there, I'm going to have to subtract it from this side. So that's going to make this portion of it factor nicely into x minus 3 quantity squared, and then I'm going to have plus 16 is equal to 0. So the nice thing about this is no quadratic formula necessary. I'm just going to move that 16 to the other side. And then we're going to take the square root of both of those sides. Square root of that, square root of that. Now, this is actually the square root of negative 16, which, remember, is not a real number, but the square root of 16 is 4, so the square root of negative 16 is 4i, and then remember we have two solutions, plus and minus. Then we'll move the 3 to the other side, and we're done. We got our solution. It's a complex number, and we got both its real and imaginary components. Okay, now we could have also done this one with the quadratic formula. It would have been doable. This one, though, you could do it with the quadratic formula, but without a calculator, those numbers are just going to explode in size. So let's try this one also with completing the square. So I'm going to start this one by trying to factor out what I can from those first two terms. 7, 35, and 50. It's like, well, that's divisible by 7 and 5, and that's divisible by 5, but not by 7, and that's not divisible by 5. So nothing gets factored out of everything. We're just going to look at those first two. Okay, so we got that factored part. Now, wishful thinking. It would be great if I had half of this, so that would be 5 over 2 negative, and we want to square that. Because it's negative and it's being squared, I'm just going to write it as plus there. So I'm adding that to that side, but I'm going to have to subtract it over here. So we got this 5 over 2 quantity squared. But I didn't really just add 5 over 2 quantity squared here, 25 fourths. I added 25 fourths times 7. That's getting distributed there too. So I got to remember to put that 7 in there. That gets distributed to all those things. Okay, so that's actually what I added, so that's what I have to subtract. Now let's simplify this. This gets kind of big here, but 25, so 5 squared is 25. 25 times 7, if you have 7 quarters, you have a $1.75, so 175 fourths, and that's equal to 0. Okay, 50 minus 175 fourths. So converting to fourths here, that's going to be 200 fourths, so I can see that that's going to become 25 fourths, and when I move it to the other side, it'll be negative. Now you might be pretty excited here to take the square root and get your 5 over 2. Well, there's our negative sign, so you'll have an I there. But remember that we still have this 7 on that side, so we got to move that to the other side's denominator. I'm going to write it like this instead of turning it into a 28, because I know where this is going. We're going to take the square root, and it'll separate out a little bit, but square root of that, square root of that. Okay, so the square root of the top over on this side, the square root of negative 25. Now you could view this as negative 1 times 25. Square root of negative 1 is I, square root of 25 is 5, so this is going to be 5i. Remember, this is all going to become plus or minus. And the denominator, the square root of 4 is 2, and the square root of 7 is root 7. So this is plus minus 5i over 2 root 7. Yuck. We could have turned it into 28. Eventually, that would become 2 root 7. Okay, so let's rationalize this. Multiplying both top and bottom there by root 7. That's what we're doing. And we come up with that, still plus or minus, and then we can move the 5 over 2 over and get this lovely number here, 5 halves plus or minus 5 root 7i all over 14. Great stuff. We could also create this as a denominator with just a single, or a fraction with just a single denominator by multiplying the left-hand sides, top and bottom, by 7. And that would look like that. Okay, thanks for watching, and Character and Scholarship for Life.